In this video, we're going to go over some limit problems that we were able to solve in Unit 1 using techniques that we developed there. And what we're going to do is we're going to see for each problem if we can apply L'Hopital's rule to calculate that limit. And if so, we're going to verify that we get the same limit that we would have gotten from the other technique. Let's see what we've got in store for us. All right, so the first problem that we have is the limit as x approaches 2 of x squared minus 4x plus 4 over x minus 2. Now, when we did this back in Unit 1, we solved that by factoring the numerator and denominator. So we had the limit as x approaches 2. The numerator factored into x minus 2 times x minus 2. And then we had x minus 2 in the denominator. So this canceled out, and that gave us the limit as x approaches 2 of x minus 2. And that we could substitute into, and we got 0 as our answer. All right, let's see if we can apply L'Hopital's rule to this problem and see what we get if we do it that way. So if we substitute 2 into this equation, what do we get? Well, 2 squared is 4, so we get 4 minus 4 times 2 is 8 plus 4 over x minus 2, which is 2 minus 2. So 4 minus 8 plus 4 is equal to 0. 2 minus 2 is equal to 0. So that is an indeterminate form. So we can use L'Hopital's rule for this. So the way we would do that is we would say that limit is equal to the limit as x approaches 2 again. And L'Hopital's rule says that we're going to take the derivative of the numerator. That's going to be our new numerator. We're going to take the derivative of the denominator. That's going to be our new denominator. We're not using the quotient rule, even though it looks like a quotient. But L'Hopital's rule says that we treat the numerator and denominator as their own functions and take their derivatives. So the derivative of 2x squared minus 4x plus 4 is 2x minus 4. And the derivative of x minus 2 is equal to 1. So let's substitute 2 into this and see if we get an indeterminate form. So 2 times 2 minus 4 is equal to 0. And 1 is just 1. Okay, is this an indeterminate form, 0 over 1? No, it's not. 0 over 0 is an indeterminate form. Infinity over infinity is an indeterminate form. But this is saying if you divided 0 cookies among one person, how many cookies does that person get? And that is not indeterminate. That has an answer. And the answer is that person gets 0 cookies. So you notice that we get the same answer of 0, whether we used our Unit 1 techniques or whether we used L'Hopital's rule. And the advantage of it is that to solve it the old way, we needed to know about factoring this quadratic expression. And to use L'Hopital's rule, we just needed to know how to find the derivatives of polynomials. Okay, second problem. The limit as x approaches infinity of x squared plus 3 over x minus 1. So when we did this in the Unit 1, we realized that this was the limit approaching infinity. So both of these things are approaching infinity. So this is an indeterminate form of infinity over infinity. But what we kind of did is we kind of waved our hands a little bit at this. And we said, well, you know, as x gets really, really big, this 3 and this 1 are going to become insignificant. It's just going to be even less and less noticeable as x gets bigger and bigger and bigger. So we might as well call this the limit of x squared over x, which equals the limit as x approaches infinity. We can cancel out an x from the numerator and denominator. And so the numerator becomes huge and the denominator stays 1. So that would be a limit of infinity. And then doing that as a shortcut, we could just say these are two polynomials, and this is getting bigger faster than this one because this exponent is higher than the invisible exponent of this. So you could take that shortcut and realize that this approaches infinity. Let's check L'Hopital's rule and see what that says. So L'Hopital's rule, once again, says that we're going to take the limit as x approaches infinity of the derivative of the numerator, which is 2x, over the derivative of the denominator, which is 1. And so can we express the limit as x approaches infinity of 2x over 1 as a number? Remember, if this is indeterminate still, we'll see examples of this in the next video, but if this is indeterminate still, we could just apply L'Hopital's rule to this new function and see what we get. But in this case, this is not indeterminate at all. This is just infinity over 1, which is another way of talking about infinity. So once again, we get the same limit either way, whether we use our understanding from Unit 1 or L'Hopital's rule. This is a case where I think our Unit 1 is kind of faster. We just needed to recognize that these are both polynomials and the numerator has a bigger leading exponent. So that's all you needed to know that the limit was infinity. But L'Hopital's rule works for us in the same case. Okay. The next problem is a limit that we have faced over and over again. So the limit as x approaches 0 of sine x over x. Remember, this was one of the important tools we needed to figure out in order to take the derivative of the sine. So this is a really important function. And we solved this back in, first thing we did is we kind of did tables and realized that this approached 1 and kind of, again, we waved our hands at it a little bit. And at the end of the unit, we talked about the squeeze rule. So we kind of said that there were two functions that were both getting closer and closer to 1 as x approached 0. And this function was in the middle of them. So it got squeezed or sandwiched at 0. And so the limit had to be 1 based on that. So the squeeze rule is a completely valid proof. There was nothing wrong with that proof. But let's see how this works when we take the limit using L'Hopital's rule. Once again, is this a case where we can use L'Hopital's rule? Let's make sure we get an indeterminate form when we substitute 0 in. The sine of 0 is equal to 0. Because remember, the sine wave looks like this. So at 0, the sine is 0. And 0 in the denominator. So that is an indeterminate form. So L'Hopital's rule says we can take the limit of the numerator. What's the limit of sine of x? Well, the limit is cosine of x. And what is the derivative of x? The derivative of x is equal to 1. Okay, is this an indeterminate form? Well, what is cosine of 0? Well, remember, cosine function looks like this. So the cosine of 0 is equal to 1 over 1. And that is obviously not indeterminate. That gives us an answer of 1, which was the same answer that we got from, it's the same answer we guessed from looking at the table where we were taking values of this with x getting smaller and smaller, closer and closer to 0. And it's also the answer we got from the squeeze function. So once again, L'Hopital's rule works for us. Last step, let's take the limit as x approaches 1 of x squared plus 3x plus 1 over x minus 5. What's this equal to? Notice that this isn't a limit as x approaches infinity, so we can't look at the exponents and immediately say that this limit is equal to infinity. All right. So the first step we should do is we should substitute 1 in for this and make sure that we have an indeterminate form. So if we've got x equals 1, then this is 1 plus 3 times 1, which is 3 plus 1 over 1 plus 5, which is equal to 5 over 6. Is that an indeterminate form? No, it is not. This is an actual number. And so back in Unit 1, we talked about Rule 1, which says that if substituting 1 in for this, when these are both continuous functions, gives us a good answer, then that's our answer. So this limit is equal to 5 over 6. And that's the correct answer to the question. But let's see what would happen if we use L'Hopital's rule on this. Let's see if L'Hopital's rule would work out for us. So the limit as x approaches 1 of, well, we've got x squared plus 3x plus 1. Its derivative is 2x plus 3. And the derivative of the denominator is just 1. So substituting 1 in for that, we've got 2 plus 3, which is 5 over 1, which is equal to 5. So notice that L'Hopital's rule does not give us the correct answer to the question. when the limit itself is not indeterminate. So this is, I went through and showed that the first three problems all gave us 0 over 0 or infinity over infinity. I wasn't just doing that to make work for myself. I was doing that to verify that L'Hopital's rule would give me an authentic answer to the question. So in the fourth question, the answer is just 5 over 6 because that's what you get when you substitute 1 in. You don't need to use any extra tricks, and the extra tricks might lead you astray. All right, in the next video, we're going to take a look at some more complicated functions and functions where honestly, L'Hopital's rule is going to save us a whole lot of headache.